Hi, boys and girls. Good morning. Um, Today we're starting chapter 9, and we're moving away from, well, not really moving away from fractions because you're going to see them come up in this chapter. We're just not doing the same skills that we've been doing with them. Okay? Everything that we've done is incorporated in this chapter, but now we're moving into measurement and data, which is the other domain. Okay? Um, these are line plots, and line plots has a lot of everything we've learned, from adding fractions, subtracting them, multiplying them, dividing them. Not so much multiplying and dividing, more so adding and subtracting. Okay. However, here's a line plot. Okay, a line plot looks like this. It's a line, and we plot the points. That's why it's called line plot. Okay, you're given a line with specific fractions in it. Okay, now these x's represent how many times 1/5 is repeated in this sequence of numbers. So if you notice, we have 3 x's for 1/5. That means 1/5 is here, here, and one more time down here. Okay, so what we do is put an X for every single time that 1/5 pops up. We're gonna do the same thing for 2/5. Okay, we're gonna count how many times 2/5 comes up in this sequence of numbers and put an X. Okay, now I can't write on this because it's not a smart board, but what I suggest you do with your pencils is scratch off every time that you count one of those numbers. So for 1/5, I should scratch off this one, and this one. It helps. First of all, it holds you accountable for how many times you're counting the fractions, and it helps you not miss counting any of them. Okay, so as you count them, scratch them off to make sure that you're, number one, counting correctly, and number two, that you're not missing any fraction. Okay, so let me grab the whiteboard, and I'm going to draw the same line plot, or try to. 1/5, 2/5, 2/5, 3, what is it? 4/5. Oops. Okay, so it goes up to 4/5. Okay, so we already know that we have color. Let me get that color. Let's use blue. 3 x's for 1/5. Okay, now let's count how many 2/5 we see in this sequence so we can plot them into the line plot. There's 1, 2, 3, 4, 5. So that means we're gonna have 5 x's for 2/5. 1, 2, 3, 4, 5. And I didn't have enough space, so I have to go over what I wrote. Okay, so 5 x's for 2/5. Now let's go back and count the 3/5. There's 1, 2, 3. So we're gonna put 3 x's, 1, 2, 3, for that fraction. And now 4/5. How many do we have? We have 1, 2, and that's it. Okay, so that's pretty much how we plot in line plots. Okay, very simple. All you have to do is count up how many 1/5 we have in that sequence and put the x's. Do the same thing for 2/5, put your x's. 3/5, how many? 4/5, how many? Okay, this is the basics. This is the easy part. Now, when they start asking us to solve, this is where we have to pay a little bit more attention. Okay, look at number 1. It says, what is the combined mass of the beads with a mass of 1/5? Now, this question is being very specific. Combined means we're going to add. They want the combined mass of the beads with a mass of 1/5 gram. So we're going to go into our line plot. Actually, I'll come to this one. And they specifically want for 1/5. So what is a combined mass for the beads that weigh 1/5? Okay, we cannot put 3. Okay, because if I put 3, I'm simply saying, okay, there are 3 beads that weigh 1/5, and that's not what they want. The question is asking for the combined mass, okay, of those beads. Now, if we have 3 beads that weigh 1/5, that means that we're adding 1/5 plus 1/5 plus 1/5, okay? You can do this 2 ways. We can add 1/5 plus 1/5 plus 1/5, or we can just multiply 3 times 1/5 because it's repeated addition, right? We can just take the shortcut and do 3 times 1/5 because each one of these is worth 1/5, right? We're saying that there are 3 beads and each one of them has a weight of 1/5 gram. Yeah, grams. Okay, so 1/5 plus 1/5 plus 1/5 we know is 3/5, okay? Because when you add your numerators, it's going to equal 3. I'll do it over here. 1/5 plus 1/5 plus 1/5. When your denominators are the same, remember that you don't have to do anything. My denominator is going to stay the same, 5. And then just add your numerators, okay? 1 plus 1 plus 1 is 3. So to answer this first question, what is the combined mass of the beads with a mass of 1/5 gram? We're going to put 3/5, okay? Now, for number 2, it says, what is the combined mass of all the beads with a mass of 2/5 gram? So same thing, combined mass, we're gonna add again all the ones that have 2/5. So coming back over here, let me erase this section here. Okay, and we're gonna add up the 2/5 section. So how many 2/5 do we have? We have 1, 2, 3, 4, 5. So that means I'm gonna add 2/5 5 times. I can either do 2/5 plus 2/5 plus 2/5 all the way up to 5 times, or I can just take the easy way out and multiply 5 times 2/5, which is better. So let's work smarter, not harder. We know how to do this because we did it in chapter 7. Okay, you have to put a 1 underneath the whole number and then multiply across. Numerator times numerator would be 10. Denominator times denominator is going to be 5. Now we know it as an improper fraction, you have to fix that, and 10 divided by 5 is going to equal 2. Okay, so all of these put together, this equals 2. Oh, and by the way, I forgot to mention earlier, I like to put the sums when I'm done adding them right next to this. So I know that for 1/5, they equal 3/5. 2/5 equals 2 because when I added, well, I multiplied 5 times 2/5 because there's 5 x's. That means each one of these weighs 2/5. I got 2. Well, we actually got 10/5 as an improper fraction and then simplified it to 2. Okay, so let's go back, and so for number 2, we're going to put the combined mass of all the beads is 2 grams. Okay, let's read number 3. What is the combined mass of all the beads on the necklace? So because it wants all the beads, this question is different. They're not asking you specifically like number 2 and number 1. Where number 1 was specifically asking us the combined mass of only one of them, 1/5. Number 2 was also only asking for a specific amount of 2/5. Number 3 wants all of them put together. So that means we're gonna have to do some more work. Okay, we're gonna have to find out the total for this one, the total for this one, because they want all of them. So I'm gonna have to find the totals. I already have it for this one and this one. I just need the total mass for 3/5 and 4/5 and then add up all of those numbers, right? So let's erase this section here. And then we can erase that too. Okay, now how many 3/5 do we have? 1, 2, 3, right? So we can do 3/5 plus 3/5 plus 3/5, or I'll do it this way because I want to work smarter, not harder. Okay, I'm going to put a 1 underneath it, and I'm going to end up with 9/5. Now this, when we simplify it, it's going to be 1 4/5, because remember that we divide. So 9 divided by 5, 5 goes into 9 one time, subtract 5. Oh, it doesn't let me write anymore. Let me see with the mouse. Nope. No. Why does it do that? That's horrible. Alright, so whole number is always the quotient. Your remainder is your numerator, and denominator is the divisor, which is the same denominator, which doesn't change. This we've been doing since chapter 6, okay? Converting improper fractions to mixed numbers. We did it last chapter, chapter 8, chapter 7, and chapter 6. For 3 chapters in a row we've been doing this, so this is not something new, okay? Let me zoom back in because it's kind of small now. Alright, so for 3/5, we got 1 4/5. So I'm going to write 1 4/5 here as our sum for 3/5. Now let's go to 4/5. Let me erase this, work over here. Okay, now for 4/5, the total is simple. We only have 2. So 4/5 plus 4/5 is going to be 8/5, because 4/5 plus 4/5, when you add it up, it's 8/5. Sorry, and then you have to convert it into a mixed number. So that would equal 1 3/5. Okay, so I'm gonna go ahead and erase this and rewrite it as 1 3/5 so that there's no confusion there, okay? All right, so our next step is to, add up everything. So once we have our total, 3/5, 2, 1 4/5, 1 3/5, they want now the combined weight. So I'm going to take all of those sums and add them up. Luckily, the denominators for this one, and this one are the same. So we're going to add those 3 first, and then we'll add the whole number last. Okay, so 1 3/5 plus 1 4/5 is going to equal 2 7/5. So we're adding these 2 first, okay? And then we'll add in the 3/5 to this as well. So 2 7/5, again, improper fraction here. We cannot leave it that way. So what we're going to do is convert it into a mixed number. For right now, we're going to pretend this 2 is in here, and we're going to focus on 7/5. When you convert 7/5 into a mixed number, you're going to get 1 2/5, because 5 goes into 7 one time, and there's going to be 2 left over. So 1 2/5 would be the mixed number for 7/5. Now remember, we have a 2 over here. So that 2 plus this 1 becomes 3. Okay, so 3 2/5 is what this becomes. Again, we've done this before. So 3 2/5, now I can add the 3/5 to this one. I've already done these 2. So I'm going to erase because I don't have enough space. So 3 2/5 plus 3/5. Okay, that's going to equal 3 5/5, because 2 plus 3 is 5, and denominators stay the same. Now 5/5 equals 1. Okay, 1 whole plus this 3 is going to equal 4. Okay, so all of this equals 4. Now we're not done. Remember, we had one more number, so we added these 2 together. we added the 3/5, and now we're missing this guy. So 4 plus 2 is 6, right? So for number 3, the combined mass of all the beads, we're gonna put 6. Okay, so let's go back and review what we did. Let me erase this section here. Here and this as well. Okay, so what did we do? Remember that in order to get this number, this number, this number, and this number, we added the x's for each fraction, and that's how we got these numbers in blue. So for 1/5, we had 1/5 plus 1/5 plus 1/5, and that was 3/5. This was 2/5 plus 2 plus 2 plus 2 plus 2, okay, which gave us 10/5, and then 10/5 was converted to 2. Then we did 3/5. 3/5 plus 3/5 plus 3/5 gave us an improper fraction, and then we converted it, and we got 1 4/5. Then for 4/5, we also added that, and it gave us 8/5, an improper fraction, which we converted to 1 3/5. Okay, and then we had to add, because they wanted the combined weight of all the beads, so we added 1 3/5 plus 1 4/5 plus 2 3/5. We no longer use these gray numbers, okay, because those gray numbers are not the sums of each of these categories. So these numbers in gray, we forget about them once we have the sums. Okay, that's how we do that. Now, the next part of the lesson is number 4. What is the average mass of the beads on the necklace? This word here, average, is something new. Okay, for example, let's forget about this for now, and let's say you wanted to find out the average of 2 of your scores. Okay, so let's say that Evangeline scored an 80% on one of her math tests, and then on another math test she scored a 90%. Okay, and she wants to know her grade, her average for these two. So what we do to find average, and this is how we calculate the grades, you add them, and that would be 170. Okay, now 170 is going to get divided by these two numbers, because to find the average, you want to know your score between 2 tests. So between these 2 tests, what's your average score? So 170 will be divided by 2, because there's 2 tests that she took. So 170, divided by 2. Okay, that would be 8, 16, 1, 10. So her average score in the grade book would be a B, 85. So this is realistic, it's real life. When you guys ask me, what would be my grade if I have an 80, and if I get a 90, what would be my grade? Well, this is how you calculate it. You add up the 2 test scores you've taken so far, get your sum, and divide it by how many tests you've taken, which in this case would be 2. So in this scenario, Evangeline's grade so far in math would be an 85%, which is a B, a solid, strong B. Okay? Now, why did I show you all of this? Because number 4 in our classwork is specifically asking you for average. So we have to take the sum, which we already did, because in number 3, we saw that the sum was 6. Okay, so this 6 over here tells us the sum for everything. It's going to be like Evangeline's test scores. She got 170. In this case, everything added up to 6, right? Now, average means that we're going to take that 6 and divide it by how many X's we have in total. Because that would be the test scores, right? Quote unquote. How many tests were taken? Well, in that case was 2, but now we're going to add up how many X's we have, the total number of X's. Okay, that's how many beads she has or how many tests we took. Okay, just an example. So here you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12,